this video, we're going to look at how to find the equation for the tangent line to a circle at a given point on the circle. If you're unfamiliar with what we mean by tangent line, if you want to know what a tangent line is, then you should watch the video in the calculus set of videos, specifically in the differentiation playlist. There is a video on finding the tangent line in there. But I'm just going to assume for this video that you know what we mean by tangent line. Briefly, it's just the straight line which touches a curve at a given point and has the same gradient as the curve at this point. So for a circle, it's a line that touches the circle at a given point and has the same gradient as the circle at that point. So let's try an example of finding such a line with a given circle. So example, confirm that the point 5, 1 lies on the circle x squared plus y squared minus 2x plus 4y minus 20 equals 0, and find the equation of the tangent to the circle at this point. So first, we assume that this equation is a circle equation because we're told it is. It's not quite in the standard form for a circle equation, but hopefully we can rewrite it so that it is as part of the solution. And what we first want to do is check that this point does indeed lie on the circle. There's no point trying to find the tangent line to this point if the point doesn't even lie on the circle. So how do we do that? We sub in x equals 5 and y equals 1 into the equation and check to see that it satisfies the equation. So what do? We just put 5 for each x and 1 for each y in the equation. So we get 5 squared, that's 25, plus 1 squared, which is 1, minus 10, plus 4y, minus 20 equals 0. And if we calculate this, we get 25 plus 1 is 26, minus 10 is 16, plus 4 is 20, minus 20 does indeed equal 0. So the equation is satisfied, so this point does lie on the circle. So now we want to find the equation to the tangent line. Well, it would help if we sketched the problem. So if we sketched the circle and the line we're looking for, and now in order to sketch this circle, we need to write the equation in the standard form. Because remember, when it's in the standard form, we can very easily read off the coordinates of the center and the radius. And when we have those two pieces of information, we can sketch it. So to do this, we complete the square. Again, we've used this method in several videos in this series, but if you're unfamiliar with it, it is explained in detail in a video in the algebra set of videos. Again, I'm just going to assume that you know how to complete the square. So we first do it for the x term. So we've got x squared minus 2x. Complete the square on that. We get x minus 1 squared minus 1. And then we also have the y terms, y squared plus 4y. Complete the square on those. We get plus y plus 2 squared minus 4. And then we still have the minus 20 equals 0. So now if we gather up all these loose numbers outside the brackets and put them on the right hand side of the equal sign, we'll have an equation in the standard form for a circle equation. So that gives us x minus 1 squared plus y plus 2 squared equals 25. And I'm just going to write that 25 as 5 squared, because now we can see the coordinates for the center of the circle and we can see that its radius is 5. So the coordinates for the center are, well, we have x minus 1 and y plus 2, which is the same as y minus minus 2. So the center has coordinates 1 minus 2, and the radius is 5, because we have that 5 squared on the right hand side. So let's put a point on our axes at 1 minus 2, which is here. And then we can draw the circle. It has a radius 5, so it looks like this. So there's the circle, and now what I'm going to do is draw a line segment going from the center of the circle to the point in question, 5, 1, which, as you can see, is here. We can see that it does indeed lie on the circle, so this looks like a good diagram. And I've labeled that line segment R. And then I'm also going to draw the tangent line that we're looking for, which is this line here, which I've labeled T. So you can see it's touching the circle at the point 5, 1, and it has the same gradient, the same rate of change or direction as the circle does at this point. Now, a very important fact is that if we have a tangent line to a circle, and we have a line segment going from the center to the point on the circle that tangent line passes through, i.e. what we have here, then the two lines must be perpendicular or at right angles. So this angle here I've marked on the diagram is a right angle. This is just something you should take for granted. We're not going to prove it in this video, but it's true that this will always be the case. And this is helpful because we know certain things about perpendicular lines, specifically about their gradients. So let's write down some information. We want to find the equation for t, that's the line we're looking for. So that's y equals m sub t x plus c sub t, where m sub t is the gradient of the line and c sub t is the y-intercept. I'm just labeling these two things with a little subscript t so that we know they relate to the tangent line t and not the other line in our diagram. So what else do we know? Well, we know that these two constants, if we find them, then we have the equation. That's all we're really trying to do, is find these two numbers which at the moment are unknown. So what else do we know? Well, we know that the line segment in the diagram R has gradient, well, we'll call its gradient m sub r to distinguish it from the gradient of t. Well, we can calculate this because we have 2 points on R. We have its endpoints, 1, minus 2, and 5, 1. So we just plug those into the definition for a gradient, and we get that the gradient is 1 minus minus 2, which is 1 plus 2, over 5 minus 1, which is, of course, 3 over 4. So the gradient for R is 3 over 4. But as we've already covered in this series of videos in a previous video, if we have two perpendicular lines, then the product of their gradients has to be minus 1. So therefore, the product of the gradients of these two lines, so mt times mr, equals minus 1. But we just said what mr was, it's 3 over 4, so this tells us that 3 over 4 times m sub t equals minus 1. And if we rearrange that, we get m sub t equals minus 4 over 3. So the gradient of the tangent line is minus 4 over 3. And now we proceed, as we have done in past problems in these videos, we write down the equation of the line. It's y equals minus 4 over 3x plus c sub t. C sub t is now the only unknown, we need to find it. But we can do that because we have a point that lies on the line, so we can sub that point in and then rearrange to find the y-intercept. So the point is 5, 1, so we know that the line passes through this point, so it must satisfy the equation. So let's sub in x equals 5 and y equals 1. What do we get? We get 1 equals minus 4 over 3 times 5 plus c sub t. This gives us that 1 equals minus 20 over 3 plus c sub t, which gives us that c sub t equals 1 plus 20 over 3. So this is just rearranging this equation. And finally, this gives us that c sub t equals 23 over 3. So we have the two unknowns we were looking for, and hence we can write down the equation of the tangent line. So the equation of the tangent line t is y equals minus 4 over 3x plus 23 over 3. And this method we use is a general method you can always use to find the tangent line to a circle at a given point.